Hey, Vlad here, devinside.com. Welcome to another video. As suspected, the previous video turned out to be the beginning of a new mini playlist related to data manipulation. Who would have thought? In the first part, aka in the previous video, we learned about Chimney, a cool library which uses macros to reduce boilerplate when converting between two data structures. And today we're going to see that this was just the beginning. In fact, we're going to keep using Chimney in the upcoming videos, but if you missed it, no worries. I structured at least this one in such a way that you can watch the one about Chimney afterwards. Today we're going to play around with Monocle, a cool library which offers a couple of tools which are collectively known as optics. Optics allow you to zoom into your potentially heavily nested data structures and manipulate them in such a way that you even forget that they were nested in the first place. To be clear, optics are a functional programming concept. So when I say manipulate, I mean in an immutable fashion, also known as creating new data structures after every manipulation. The example that I have given you just now applies to a particular optic called lens, which not coincidentally happens to be the most prominent optic, and quite frankly for a good reason, which is also why it is the topic of this video. There are other optics inside Monocle, and we will cover them in the upcoming videos. For now, let's just roll the intro. As in most of my videos, I'm on Windows 10 and I'm running an Ubuntu 18.04 virtual machine, and I'm using the virtual desktop feature from Windows, which gives me shortcuts which allow me to switch between my desktop like so. I'm on Windows and I'm back to Ubuntu. Alright, so the way this video is structured is we're going to start exactly where we left off in the previous video. We're going to clean up the example just a little bit. It's going to take just a couple of minutes, and if you're in a rush, there will be timestamps in the description below. After we finish the cleanup process, I'm going to demonstrate the problem that lenses are solving without adding Monocle to the class bus. Because what we're going to do today is we're going to develop our own version of lenses, and I'm going to drive the design in such a way that by the end of the video we're going to end up with exactly the same implementation as in Monocle. And so we will add Monocle to the class path, throw out our entire implementation, and everything will still work. Alright, so my original plan was to clean this up with you guys so that you see all the changes, but I realized that it's going to take forever. So what I did was I removed all the imports, and we have a simple main where we're constructing the flat person, then we're converting it to nested, we're printing both of them out. This is exactly what you see here, and the whole validation example is now over here in validated example. It now has a simple def that you can just give it a nested person. It will run through this whole example, to the whole validation and return it, and it has this tiny helper int or error message. And also, I'm usually when I'm recording, I'm using a very large font, but I'm starting to realize that it just doesn't work anymore. I'm gonna lower it a little bit, and you guys feel free to let me know if this is too much. So if this is too small, yes, over here, let's go from 22 to 20. It should still be fine, because otherwise I'm going to be fighting for space way too much. All right, so we're back to our main method again. We just have a flat person and we have a nested person, and we're just printing them out, and that's all that we're doing. All right, so let me create some more space, and let's start with the problem that lenses are solving. Okay, let's say that we wanted to write a function called setStreetName. SetStreetName, which we can give a nested person like this, and we can give it a new street name with a string, and we want to produce another nested one. How are we going to implement it? Well, we know that case classes have the copy method. The problem is that we're dealing with a nested structure, so we need to go down and call copy again and again. Let me show this to you. So we need to go and say nested copy. Okay, and then we're going to do this, and then we're going to say, okay, which field do we want to modify? Well, we want to modify the address, and we're going to do nested dot address dot, and we need to copy again. Okay, and inside of it we want to do the street. Okay, it's going to be nested dot address dot street dot copy. Okay, and now we can finally have access to our nested field called name, and now we can finally set it to the new street name. Okay, new street name like this. All right, now we're going to deal mostly with the flat and nested versions. So what I'm going to do at the top is I'm going to just import it, import person.raw like this. Okay, and now over here we can do that. We can just construct a flat like that, and over here we can just do nested like that. Okay, now everything should compile. Now I want to have a fair comparison with Monocle, and I don't like the way Scala FMT formats this. So what I'm going to do is I'm going to do format off like this, and I'm going to duplicate the line. And for some reason, if I'm bringing this line, VS Code ruins the entire formatting. I have no idea why it does that. This is super annoying. Okay, format on like this. So what I'm going to do is I'm going to switch it to on real quick. I'm going to press save. Okay, and now I'm going to switch it back to off so that I can join these lines over here. Okay, so I want it to be written like this. Okay, join these lines as well. One more like this. like that, and like that, and I want to bring these two like that, and these two like that. Okay, so this is what we have right now. I'm also going to have a tiny helper function. I'm going to call it styled, right? So it's just going to get a string in, and the string comes out, and we're just going to do console.green plus in plus console dot reset like this. Okay, and now we can just print it out. In fact, let's duplicate this one like this so that we see the flat and the nested version, and over here we're going to see print line. We're going to do set street name. We're going to pass in the nested version, and as the new value we're just simply going to pass in the styled version of some new street, right? So I'm using the style function just so that you can clearly visibly see where the changes, because this is a lot of print lines. Now if you wanted to have an example where we modify the street, it would actually look exactly the same, right? So if we do that, and I'm going to press enter a couple of times, and I'm going to paste that. I'm sometimes pressing Control Shift V because I'm used to pressing this from Sublime. This would be like paste without formatting. VS Code doesn't understand that. I should fix this at some point. Okay, so I'm going to paste that like this. Okay, so I'm going to come on, move it. I'm going to call it modify a street name like this, and now it doesn't get the new street name. It gets a function called transform, which basically takes a string and produces another string. Okay, and now in order to call transform, we actually need to pass it the original value. Transform, the original value is nested dot address dot street dot name like this. Okay, so now we can actually go and we can do it over here. We can do modify, and styled matches exactly the signature, right? So style is a function that takes a string and produces a string. So basically the Fifth Avenue, it became green. Now this is obviously annoying to write, and this is exactly the problem that Lenses are trying to solve. So if I'm going to copy this and I'm going to insert it over here, right? I'm going to call it modify street name 2. Then if we had Monocle on our class path, then we would be able to do something like this. Hey Monocle, please generate a lens for the nested person, and please generate it for the field name.address.street name like this. Now this lens is an object, and it has methods like set and modify and so on, right? So we would just be able to say dot modify transform like this, right? And this whole thing would produce a function that takes a nested person and produces a nested person, okay, by applying this transform function somewhere inside. So all we need to do is we need to give it the nested person, right? So this would be the entire code. This is not going to compile right now, obviously, because we don't have Monocle on our class path. But if we had Monocle, it would actually compile, and it would work exactly like this. And in fact, Monocle has even more syntactic sugar on top of that. So the other version would be to say nested dot please give me the lens, and then inside of it we're going to do exactly that thing, right? So exactly that thing would go over here, right? So this is even shorter, okay? And by the end of this video we're going to include Monocle, and this is exactly what we're going to have. For now we're just going to derive our own implementation of Lenses. So let's comment this one out, and because it's not going to compile, right? So I'm just going to cut it out, and I'm just going to bring it somewhere even below main. I'm just going to leave it somewhere there. In fact, by the end of the video, we'll be able to just uncomment it, and it's still going to work. All right, so first of all, just for the sake of symmetry, we have set street name and we have modify street name. Let's also have get street name, right? Get street name like this. It gets in a nested, produces a string like this, okay? And it just goes into nested.address.street.name. Like this, right? Nothing super fancy. Let's go over here. Let's do get street name like this. Just give it a nested like that. Okay, so now we can start implementing them in terms of each other, right? So for example, over here, when we're going to modify a street name, we're actually getting out the current value, and this is exactly what get street name is doing, right? So we can do, for example, over here, we can go and we can say get street name, and we can pass in nested. Okay, and then obviously we can implement set in terms of modify, right? So we can just call modify street name like this over here, right? And we can just pass in so we need to pass in nested, right? But then we can also pass a function that will take the input, not do anything with the input, and just set it to a new street name. And if you look over here, nothing is going to change. This is exactly the same implementation, and in fact now we can remove this formatting stuff. Now we could also go the other way around, right? We could implement modify in terms of set, and in fact this is what we will end up doing by the end of the video. But for now I'm going to show you that this thing will actually create a worse user experience for our users. So for now we're just going to keep going with this design. So the next thing that we're going to do is we're just going to put all of these three into an object called street name lens, like this, right? Curly brace over here, curly brace over here, right? So now these guys can just be called set. This one can be called modify, right? Modify, like this. And this one can just be called get over here as well. Let me save the file. Let's see what it does. All right, that looks not too bad. Okay, like this and like that. Okay, so now over here we can essentially go and we can create our lens, right, which is going to be just street name lens. And now we can just use this lens and do dot set. Over here we can do lens dot modify, and over here we can do lens dot get, like this. And it compiles, it does exactly the same thing, you know, it's just a bit more object oriented, I guess. We just put all of them into this object. Now eventually this thing is going to be called just lens, and it's not going to be an object, it's going to be a class or maybe even a trait, but we can already take it out and put it in its own class. Okay, so it's in its own file, I mean. Okay, so we're just going to take it out. I'm going to go over here, I'm going to right click, I'm going to say new file, I'm just going to call it lens.scala. Okay, just going to paste it in like that, and I'm going to do that over here, and I'm going to, at least for now, we're going to import person.raw, like that. Okay, still exactly the same code, behaves exactly the same. Okay, but now we have our tiny main was flat, was nested, we're printing both of them out, we have this tiny helper styled, we're creating our lens, you know, we're just assigning the same object to another variable, and we're working with the lens over here. Okay, let me create more space like that. So as I already mentioned, I want to drive the design in such a way that it looks more and more like in Monocle. So in Monocle, function currying is used over here. So this is just going to be two different parameter lists, like that, like that. Okay, and if you're not familiar with function currying, long time ago I made a video about this. Okay, function currying like that. Now we need to go to main and we need to fix that. So instead of the comma, essentially we're going to have a closing brace and an opening brace, like that. Not a big deal. All right, the next thing that we're going to do is we're going to go and we're going to swap the parameter list. For some reason they're swapped, right? So this one goes first, and this one goes first, like that. And for that reason we also need to swap these guys like that. Okay, and then we need to go to main and we need to do the same thing. We're going to take this one and put it over here. We're going to take that one and put it over here. I think that should be enough. Yep, that's enough. The next thing that Monocle is doing is it doesn't use this fancy syntax for function currying, right? So when you declare functions, you know, you have this fancy syntax with multiple parameter lists. So instead, what it does, it says, you know, we're gonna just return a function from nested to nested, like this. Okay, so it's exactly the same thing, but now nested is gonna come in like that. Okay, and the same thing over here, right? So it's just going to be it's just going to return a function from nested to nested. Okay, and the nested is going to come in over here like that. Now we need to move everything like this. Okay, the entire code should not change, and in fact right now we could also just do that, right? Because we're using nested only once, right? So this is a parameter that we're using only once. So we can just throw this out, and we can also throw that out, right? It's going to behave exactly the same. In fact, now something is messed up with the formatting. Hold up. It should be like this. Okay, now this signature is starting to look really weird and really complicated, and this is exactly why I'm making this video, because if you jump into lenses, jump into Monocle, you're going to see signatures like this all over the place. This is exactly why I'm making this video. This is exactly why we're deriving the lenses from scratch. All right, so let's generalize this a little bit so that we can create lenses for other things and for other fields. So this is not going to be an object anymore, and it's going to be just called lens. This is going to be an abstract class. So set is going to be a final def now, because it can be implemented in terms of modify, but for modify we actually can't implement anything like this over here, because now we don't know which field we're working with, right? So in fact I forgot to rename this one, right? So this is just going to be a new value, but we don't know for which field this lens is going to be in. It's not called lens, it's called lens. like this. Okay, so basically we can't do any of that stuff over here, and for now I'm going to just comment it out, right? So essentially this modify function is going to become abstract, and the same thing for get. We don't really know which field we're working with, so we would need to comment this out like this. Okay, and now in our main we would need to go and we would need to create a new instance of the lens. So in fact I'm going to call this one street name, right? Street name. I'm just going to call it street name. This is sort of like a convention. You know, you don't want to use the Hungarian notation. You don't want to call it street name lens because the lens is going to be in the type anyway. So just call it street name. Okay, so this is going to be a new lens like this. And in fact, if we save that, maybe Bloop is going to be able to help us out. Bloop and metals. No, it can't. Does lens compile? Hold up. It does. Okay, why doesn't it? Maybe I need to do, hold on, override. Override. No, it doesn't help us. All right. So let's go and just do that. For some reason, it doesn't like me today. All right, so we're just going to do that. And we're also going to do that over here. Right, so essentially we just need to move the implementation that we commented out over here. Okay, so actually we could have taken the entire implementation right away like this. Let's put it over here and let's do the lens nested like that. Let's go and put it over here like this. Let's save, and it looks like it works. So now we can remove all of that crap and make it look a little bit better, like that. In fact, I kind of want to make, put get at the top. Let's put get and modify the top, right? So these are abstract. Okay, let's also put this import over here. Okay, so now we have this tiny abstract lens. If we go here, I'm going to leave it like this for now. Okay, I don't want to do, I'm going to allow Scala FMT to format the entire thing, right? So basically we have our modify and we have our get, but now everything is a little bit more abstracted away. So now we could actually go and we could create a lens for a zip code, for example. I'm going to collapse that. I'm going to take this. I'm going to go down over here. I'm going to paste that. I'm going to call it city zip code like this, and we're just going to go down over here, and this is not going to be that. This is going to be city dot zip code like this, and we also need to go to modify and make sure that we go to nested address, and now not street. We're going to go to city, and we're going to say nested address city copy, and we're not copying the name, we're copying the zip code like this. Okay, so now we have the city zip code. We can copy these ones. We can go down over here, for example. We can paste that, and we can say that we want to work with the zip code, which I call city zip code, I think. Yeah, city zip code, like that. Okay. All right, so we're doing the same modification, but now it's for the zip code. Over here we have the street name. Over here we're doing the zip code. Maybe we should do over here new zip code like this. All right, cool. So now we can sort of abstract a little bit we can abstract the fields away, right? So we can decide which field we want to go to. Now, as I said, I want to keep the design as possible to Monocle so that we can switch to it without any hassle. So Monocle also has a factory method where you can, basically give these two functions, and it will create an instance of the last lens for you. In fact, what we will be able to do is we will even be able to seal this abstract class. Okay, so what we should be able to do is we need to go to create an object lens. Okay, it's the same name. We're going to create a function apply, right? And again, the idea is that we're going to pass it the get function, right? Which is going to have, this signature, which is a function that takes a nested and produces a nested, and we're going to pass it the modify, right? And the signature for modify is a bit weird, right? So it basically says, okay, if you can give me a function that takes a string and produces a string, right? This transform function, well, then I will be able to produce a function for you that takes a nested and produces a nested. Okay, and this entire thing is going to produce a lens. So all we need to do is we need to go and say new lens like this. Okay, and we're just going to define get nested produces a string. Well, it's just going to call get was a nested, and we're going to do the same thing for modify. In fact, maybe I can just duplicate that, bring it down, and VS Code is going to format the entire thing for me in a weird way for some reason. And I'm just going to do equals over here, and I'm going to do modify. We're just going to pass in transform like this. Okay, so this doesn't compile for some reason. Once raw nested required string. Oh yeah, this function should produce a string. right? String, like this. Okay, so now this thing compiles, but our main doesn't compile because we sealed this, right? So if I remove that, then it still works, right? So I'm gonna unseal it, and we're gonna go to main, and we need to go over here. So instead of saying new lens over here, we're just gonna say lens, okay? And then this is sort of gonna be curried like that, like that, and like that. Okay, so now, but instead of overriding these stuff, we can just remove all of that crap like this. So the first one is get. Hold on. So the first one needs to be, you know what? Let's remove the whole thing. Let's remove the whole thing. Okay, let's remove the whole thing. Okay, so we're just going to do lens over here, and the first function is a get. So we just need to go underscore address dot city dot zip code, and the other one is modify, right? And the modify is going to look like this. In fact, now I'm going to copy it from street name. I'm going to take this. Oh man, see, this is exactly what I hate about VS Code. So let's go and paste it in over here, and then we need to make sure that again we're going to nested address, copy street. That's not going to be street, that's going to be city. And we're going to go over here, city, and this is going to be zip code. And yeah, and this is the problem with our implementation, that we can't call get anymore because we don't have it. Okay, get is now over there. So we need to do nested dot and then basically paste that thing in there. This is exactly why we're going to change our design in just a couple of seconds. Okay, so let's unspecified value parameter modify. Really? Did I forget to curry them? Oh yeah, I wanted to curry them actually, like that. Okay, and this is exactly how it's done in Monocle. Okay, let's save that. What? It doesn't like that? Hold up. 59 nested value copy is not a member of string. Oh yeah, so this is not okay. So this is transform, right? And this one is nested like this, right? This is a complicated function, remember? So this is a function that it starts with transform, right? So if you give me the function that can transform, right? So if we have this function over here, and then I will be able to produce a function that takes a nested over here and produces another nested over there. Okay, so let me actually go and copy that and go into this one, just paste it over here like this, and just to make sure that this goes into the street dot name, this goes into street, and this goes into street, and this goes into name, and over here street and name. I believe I did it right. Yes, I did, right? So now our code behaves exactly the same. So this is a little bit nicer, but it still looks very complicated. And the problem is that we're ending up specifying like that part twice, right? So if you go over here, then you're going to see that we're ending up specifying it twice. And this is exactly the problem that that happened because we implemented set in terms of modify and not the other way around. If we swap them, then the problem will be solved, because over here, then we will say, it would be better if we didn't have transform, if we just had new value, right? So if you already had the new value, then we would just be able to specify it over here like this, new value, right? But as of right now, it's not going to compile. Okay, so what we're going to do is we're going to go and we're going to switch it, right? So we're not going to say final def set over here. We're going to say final def modify, right? Final def modify, and we're going to go and put set over here. We're going to make it abstract like this. Okay, and now all we need to do is we need to implement modify in terms of set. This signature looks really, really weird, and in fact the implementation is going to be a little bit more complicated, but in fact if you start looking at it, it's actually not going to be that complicated. Okay, so we're just going to have a scope over here, and we're going to say, okay, so let's start. So what we need to produce is like with these functions, with highly parametric functions, and with highly with higher order functions, right? Because this is a high order function, not only because it takes a function as an argument, but also because it produces a function. So every time you need to produce a function, you just need to start writing it. Okay, so this is going to be a function that takes a nested, and now somehow we need to produce a nested over here. Okay, well, what we can do is we can get the current value by just calling get, right? So we can call it get nested. Okay, and we have the current value. Now we can get the new value by just calling transform on the current value. Okay, and now we can produce the new nested, okay, somehow, and in the end we're just gonna return the new nested, okay, new nested, okay. And how are we going to do this? Well, the only thing that we can do is we can basically just call sat, right? We can call sat with a new value, and we can call it with nested, like this. And this is already the implementation. New nested, new nested. What's your problem? Illegal start of declaration. What did I do? I forgot the equal sign. Equal sign. There we go. Okay, so now it compiles. We just need to go down and make sure that over here we want just a sat, which is just a function that takes a string. Okay, produces nested to nested, and we're gonna do def set over here, which is just going to be set. No, it's gonna be called transform. Okay, string to string, same thing. Just gonna call set like this. All right, it almost compiles. No, this should be just new value, new value, new value, string, like that. Set new value. Okay. Cool. So now all we need to do is we need to go to main, and we just need to say over here that we already have the new value, and therefore we can just go and use it over here. New value. And the same thing for zip code. It's at the bottom. Okay. So if we already had the new value, then we can go and use the new value over here. New value, like this. Okay, and now our code is doing exactly the same thing, but the client-facing API is much better. In fact, I want you guys, if you're watching my videos, I want you guys to have, to have this sort of spidey sense for bad code, right? So if you have this, it's called a code smell, then I want you to be able to have the courage and go and actually rewrite your stuff. So our lenses are pretty much done. We can try to minimize a few things here. We can do that, and we can do that. Maybe Scala FMT is going to be happy with that. We can also start inlining this whole thing. Okay, so current value is used only once, so we can just go and use it over here. Now we're not going to need this. Now new value is also used only once, so we can go and use it over here. Now we're not gonna need that. Okay, now new nested is used only once, so we can just throw the whole thing like this, like that. And now that it's just one thing, one expression, we can also remove these curly braces, and maybe we can also press enter over here, and that's how it's going to look like. And this is exactly how it also looks in Monocle. Remember the trick that we did with set, that we were just able to remove this and remove that? We can't do that trick in here because we're actually using nested twice. All right, so this thing is now super cute. It's just a couple of lines. Okay, like 20 lines. So all we need to do is we need to sprinkle a bit of parametric polymorphism on top so that we can work with not only fields of strings and also not only with nested. Okay, so we're going to start with having the type parameter for source, right? So we're going to say that we need to be able to specify the source. So everywhere where we say nested, I'm going to do this. We're just going to say source, and the value, the variable that is called nested, we're just going to call it source. And now we need to not forget that the apply now also wants the source, and when we're creating a new lens, we need to specify the parameter. We don't need to, but when I'm recording tutorials, I'm trying to specify all the possible, all the necessary types. Okay, so we have the sources everywhere, I think, and the next thing that we need is we are going to call it target, and in Monocle it's called S and A. Okay, so it's S and A. Okay. Okay, by the way, we're not going to need this import once we're done. Okay, so now every time we're going to say new value, we're just going to say target. Okay, and every time we have string, we're just going to say target. Okay, so now we just need to go to main, and oh, we forgot target over here, right? Target over here, and over here. Target, right? Because lens is now parameterized. Okay, so this whole thing compiles. We just need to go back to our main, and we need to specify the types. Okay, so this is the lens that goes from nested, it zooms into a string, and the other one does exactly the same thing. This is a lens that goes from nested and zooms into a string, like this. Great. works exactly the same, but now it will work with other types as well and with other people as well. In fact, just to demonstrate that, maybe we should go and work with our example from validation. Okay, so remember we in the beginning of the video we moved everything into this validation example. I think I call it validated example. I want to call it validation example. Hold on. I'm gonna call it validation like this, and I'm gonna rename the file as well. Not that, I want that. Rename that validation example like this. All right, so let's go back to our main. We can do validation example. Okay, so we can ask it to try to validate a person. We're just gonna give it the nested, and if you remember correctly, then you know the type of this is validated.valid person. I'm sorry, that was supposed to say person, right? Which is a validated nag of string, and a person, which, in case you're not familiar with cats, is just a validated with a non-empty chain for arrows of string, and on the right side you have our person, right? So this is the type, right? And because of that, we can call map. In fact, I think Scala FMT is going to ruin my comments, so I'm going to remove it. Okay, so we can call map, and over here we're going to have our person, and we can do something with that person, right? So we're going to try to modify that person, and then by the end we're just gonna print it out. Okay, so over here what we can do is we can now create a lens, right? We can create a lens that goes from person to person.age. Right. Remember, this is not the raw version. This is the the complicated one with with all the any-val case classes and so on. Okay, so we can have that, and we can just say, okay, please go to age. Right. So this is our get, and our modify. Because we're still using, we're using a very flat one, right? So this is not a demonstration of lenses anymore. This is just a demonstration of, not of the demonstration of the benefit of lenses. I just want to have a simple example. Okay, so now we need to pass in a function that takes a source, right? Remember, source used to be called new value, and we're just going to do source.copy age equals target. Okay, like this. So now we have this lens, and now because we're working with these weird types, right? So if I jump into age, this is just a case class, it's just a wrapper around an integer. Okay, our transform is going to look a bit weird. In fact, we're going to solve this in the next video once we're going to talk about isomorphisms and lens and other optic composition, right? So we're going to have a function for now that just does this weird stuff where it creates a new person age with age.value, and let's say that our modification is just going to be plus 10. Okay, so now that we have both of these, now we can use our lens to modify the person. Okay, we can do transform, and we can do person, and if I did everything correctly, then our age should go from 21 to 31. Okay, so now you see that the lens doesn't only work for nested and flat, it also works for person, and also works for other types and not just strings. All right, now that we have that, we can actually go include Monocle and throw out our entire implementation. So if I go to a website called Julien Truffaut, I think he's French. I'm not gonna even try to butcher this. So the link is gonna be down in the description. And if we click on modules, you're gonna see all the modules that you can include. In fact, yeah, 150 should be fine. Okay, so it looks like it's a bunch of modules, but the ones that we need is basically just this one. This is the Monocle macro, and this is also the one that has the dependency on Monocle core, right? So you need at least the core, but we're gonna, the biggest benefit, according to me, comes from the macro implementation in Monocle. Okay, so we're just going to use this one, and it's going to bring the dependency on core, and Monocle also has a dependency on cats, so we will actually even be able to throw out cats, okay, because it depends on it. Okay, I'm just going to explain real quick what the others do. So we're also going to use the one for the laws, because all the optics inside of Monocle, they need to abide by some mathematical laws, but we're going to do this in the next video. It basically has a helpers for you. This one is an integration with a shapeless. Actually, they're described over here, right? So you can read it for you. You can read it yourself. Okay, there's basically the others are integrations with other libraries. All right, so I'm gonna grab this from my script because I already have it prepared. Okay, so if we go back to my VM and I'm gonna open the dependencies file, so we have our cats, we have the kind projector, we have our test, we have our util, and what I have prepared for you is this object Monocle. Okay, so this is basically all these dependencies that you just saw on this website. We have just a bunch of these vowels, but we're not going to use all of them. In fact, we're going to use only this one. Okay, so if I'm going to go back to our build like this, then we're going to go, and so over here we have the production dependencies, and over here we have the test dependencies. Okay, so all we need to do is I'm just going to go, and under chimney I'm going to say dependencies dot util dot monocle dot, and now we can just do that. Okay, and in fact, as I already mentioned, we actually don't need cat's core anymore because we have the dependency on monocle, and it has a dependency on cats. Okay, let's not forget to import the build for Bloop. So while it imports, we can actually go to our main. We can pretty much throw out our lens, right? So our lens implementation, we're just gonna throw it out, which is just a couple of lines, 22 lines. We go to our main over here. Now it complains that it doesn't know what the lens is, and we can go over here and we can just say import monocle dot lens, like this pretty much. Okay, and actually Bloop finished as well. Now everything compiles, everything works exactly the same, but now if we jump into lens, we're going to see that we're inside of Monocle. We're also going to see a polymorphic lens over here, which we can pretty much ignore. So we're calling apply, and it just goes to plens.apply. So I'm just going to go in there, and we're going to find the apply, which is over here, which is doing, you can ignore that part, but it basically does exactly the same thing, right? So this modify function does exactly what we're doing. In fact, if I go back to our lens, and I'm going to copy that, okay, I'm going to go over here, I'm going to paste it over here, and I'm going to just go and rename a couple of things, right? So this S over here, this is source, this is source, this is source. The F is called transform, and they're pretty much calling the underscore get and underscore set just as an optimization, I guess, right? But the compiler should inline this anyway, right? So as you can see, this is exactly the same thing. It's just the parameters are called S and A and not source and target. All right, so I'm going to revert that. I'm going to do that. Okay, go back to our main. Now, the biggest thing that comes from Monocle is this macro-based generation of lenses. Okay, so if we import also, well, in fact, not also, we actually need only one of them, but for now I'm gonna do monocle.macros, and inside of there it has gen lens, right? So gen lens will generate a lens, but what it will produce will have the type of lens. Okay, so in fact, I'm gonna go and I'm gonna specify the types on the left as well. So just so that everything is super crystal clear. Okay, so on the left we're still gonna have a lens, and over here we still have a lens like this. Okay, so what we can do now is we can basically, instead of calling lens.apply, we can call genLens.apply. Okay, and now we don't need to specify this entire modify thing, right? We can just throw it out and macros will generate it for us. And in fact, it's done in such a way that we don't even need to specify that the type of our field is a string, right? It will be able to figure this out on its own. Okay, so this is the entire creation of the lens. We just need to specify which field, and it will go and it will create the modify function for us. Now we can go and do the same thing for a zip code, which is over here. We just do gen, we're throwing out the type of the field, and we're throwing out the entire modifier, which goes until here like this. And our code still behaves exactly the same, does exactly the same thing, and as you can see at the bottom, this is exactly the same, and it also has this a fancy syntax. So if we go and import one more thing, if we import I believe it's called syntax, right? Syntax underscore like this. No, I think we need to do lens dot underscore like that, and now we can actually go and create a lens in a different way. It's just that we can't insert it over here, right? Because this fancy syntax, it already needs a nested to produce the lens, right? So basically it works for the cases where you inline stuff, right? So if I take this and everywhere we say street name, we're gonna do that, right? So there's a syntax to do that nicer. So in fact, this huge line instead of that, so we basically need to take nested and move it over here, and then we can call dot lens on it like this, and it should do exactly the same thing. Now we don't need these parentheses. Okay, and now we can maybe join lines, and now we can see that this is even shorter, right? So to create this lens, it's shorter because we don't need to specify any types, right? Super short. Right, this is really fancy syntax. All right, now this was just the beginning of us playing around with Monocle, and even though macros is the biggest advantage, according to me, this is not the only reason to use Monocle. The first reason is that, as already mentioned, Monocle has way more optics, not just lens, just that the lens is the most prominent one. The second reason is that we just played with get, set, and modify, but Monocle has actually a bunch of more very useful helpers, and one of them is in fact, multiple of them is the functions that allow you to compose lenses together. This is probably even an even bigger benefit than macros, right? So we're gonna have examples of this in the next video. In fact, let me show this to you real quick. So over here we're creating a street name just right away, and I'll be honest, this is the fastest way to do it. But just as a demonstration of composition, what we'll be able to do is I'm gonna create a space over here. Okay. I'm going to remove that, right? So what we could do is we could say, okay, please generate a lens that goes from nested just into the address. Okay, and now we will be able to compose that, right? So we're doing compose lens because you can also do compose some other optic. Okay, compose lens. Please compose it with a lens that basically starts with the address dot raw and goes into street, right? So we're basically doing this one by one. And can you please also compose that one with a lens that now starts with a street dot raw and goes into dot name, right? This is going to be exactly the same lens, and because we're still using it over here, our code is going to behave exactly the same. And I made a typo, and by the way, look at this Levenstein's distance, the new thing in SBT 1.3, I believe. All right, and in fact, let's do this with the dot. So let's do a dot over here. Let's wrap this in parens. Let's do a dot over here, and let's wrap this thing in parens over here. This whole infix notation, it doesn't really scale. Okay, that's crap now, like that. Okay, yeah, so like that it looks much better. Okay, so we basically we're doing the same thing, right? So we wanted to go from nested to string. We just composed a couple of lenses together. So we went from nested to string, but through the address, through the street, and so on. One last thing that I'm going to show you is that Monocle also comes in with white box macros, and for that you actually need a plugin. In fact, if I go back to the website, in fact I think I need to go to no, over here. So this is a plugin that you would need to add if you're still on Scala 2.12. However, in Scala 2.13 this plugin was merged into Scala, and now you can just enable it with just a flag. So if I go back to my build, I'm going to see that I have a couple of flags commented out, and one of them is this one, macro annotations, right? So if you enable this flag, we need to come over here, and then it's going to work. And let's not forget to import the build. Okay, so the idea is that what you can do now is we can go into our structure where we have all of these case classes. Okay, and we can mark all of these case classes, and we can put an annotation there. It's called lenses, like this. Okay, we actually need to not forget to import. I can actually steal it from our main. Let's just, I think it's over there. Like this. Okay, so Bloop is actually happy. Our entire code still, no, almost, no. Okay, so one problem that is happening over here, that it actually, so what it does is it generates lenses and it puts them into the companion objects. Okay, but for some reason, the companion objects are not marked with case, and therefore they don't extend a function, basically extend the factor, right? So so there should, for example, for this name, there should be a in fact, let's actually do this with these arrows. Okay, so our problem is that height in centimeters, okay, over here, that we're using this in the validation example, that we're using them as functions, right? So if I do dot apply over here, and the entire code is still going to work, it's just that our print lines are going to be fucked up, and I'm going to explain this in just a couple of seconds. Okay, come on, it should work now. What's happening? Why is it still red? Bloop should understand. Hold up. Bloop should understand that this is fine as well. I just imported the build, didn't I? Hold up, let me open it again. I don't know. Let's import the build again. I want Bloop to be happy as well. Okay, but essentially, if I remove that, it's not going to compile. It's not going to compile. Okay, and if you wanted to fix it, we need to go to structure, and we would need to do something like this: case object case object height in centimeters, and we need to say that it extends a function, right, that takes an integer and produce a height in centimeters, right? And then we're gonna have like one error less, and we can duplicate that, and we can do the same thing for age, okay, like this. Okay, and now the same thing is going to work. And also, because I'm using basically the toString of all of these case objects for person and age, all of our print lines are now ruined because as I said, as soon as you have this @lenses annotation, then the object that is being generated is not going to be a case object, it's going to be a regular object. So I already fixed it in my script for you. Basically, I went everywhere, and instead of this, I said person.age. Okay, now at least person.age is going to be fixed somewhere over there. Where's person.age? Name age over here, right? So at least this one is fixed. So I'm just going to copy that from my script. Right, I'm going to copy that. I'm going to go to a structure, and I'm just going to replace the entire file like that. Right, so basically I just went ahead and everywhere I used the strings. Okay, and now all of the strings are fixed. So what it allows us to do is we can go over here where we're doing for example, this composition. Okay, so instead of that we can just do, I'm going to do it above. Okay, I'm going to do it over here. So we can just go to nested, to the companion object, and inside of it there already is a lens for address. Right, Bloop is still not happy. Okay, but believe me, there is a lens. Okay, so we can do nested.address. Okay, and now we can do compose lens, right? And we can do nested we can do address.raw.street, right? Another lens, and we're gonna compose that one, compose lens. Okay, with street.raw.name, right? So all of the companion objects, they now have this lens. Okay, so I can remove this and our code will still behave exactly the same. Okay, I'm not a big fan of that, but you do you. If you like that, go for it. All right, I hope you enjoyed the first video about Monocle, which is also the second video in the playlist about data manipulation. The first one was about Chimney, and we haven't done much with Chimney today, but in fact we're going to go back to it in the next video and see how we can use Monocle together with Chimney, and more importantly how we can write the laws, and how we can make sure that the lenses and all the other optics that we're generating, how we can make sure that they abide to other laws, which is to mathematical laws, which is really important, but we obviously didn't have time for it in this video. And yeah, as always, it's been Vlad, DevInsideYou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon. But most importantly, take care.